Welcome to lesson 2, slope. This is the second lesson for week number 5 and part of our line unit. Today we're going to look at how to figure out slope from a graph and from 2 points on a line. We're going to start off with just taking a look at what is slope. Slope is the idea of basically as numbers on your line increase in the x direction, how much are they increasing in the y direction? A more regular term version of this is we're measuring the steepness of a straight line. So we're taking any straight line. How steep is it? We're going to look at 4 types of slope here. The first 2 that we're taking a look at, I'll kind of scroll out there for a second so you can see all 4 to start. You can see that there are 4 different types of lines here and they're all a little bit different. The idea of figuring out what type of slope it is think about almost as if you're walking across the line. So I'm going to look at the first 2, scroll in a little bit more. With these first 2 lines, if you were walking along the line and you walked from basically the beginning of the line and working through, you would go upwards. Always reading your lines from left to right. So as we go from left to right, your numbers in the y are getting larger. This is what we call positive slope. And that's because the graph is going up in the positive direction. When you see an equation for a line, it will always be something where there's a value in front of x. It'll look something like this. Y equals, this particular one is 3x. And it's positive because this number in front is also a positive number. So that's what helps in the equation to tell you it's a positive slope. The other scenario you get is you potentially will be on a line, and instead of it going upwards, when you go from left to right, it actually is going downwards now. And if you're going in the downwards direction, well, that looks pretty opposite to this one. What's the opposite of positive? Yep, negative. So this is a negative slope, and a negative slope will look like it's decreasing as you read it from left to right. The equation will also look a little bit different where, hopefully you can guess it, this number in front of the x will be negative. Hence, it's called negative slope. So that kind of makes some sense. So those 2 are the 2 that you're going to see the most in the unit, but there are a couple other scenarios that do come up. Sometimes you get situations where lines are perfectly flat. This is a horizontal scenario, and if you actually tried to walk across this line, there is no increase or decrease in the vertical direction. You're staying on the same point all the way through. And this particular line always crosses through the exact same point. Y equals 2, 4. Be careful reading scale when you're doing these. These scales go up by 10s here. So we got 2, 4 going up by 2s up to 10. And this particular one has what we call a 0 slope or no slope, because it's a perfectly flat line. It's like the idea if you're walking across a perfectly flat classroom or hallway or the room in your house, you're not going uphill or downhill normally. It would be what we call a 0 slope. It's perfectly flat. Then you get this unusual scenario where you get a slope that's completely vertical, all up and down. And instead of, oh, I apologize for this last one, that should just be y equals 4, not y equals 4x. There is no 4x value on that one. That's because everywhere on this line, y always equals 4. X is 10, y is 4. X is 20, y is 4. X is negative 10, y is 4. In this case, this line is a perfectly vertical line. And it doesn't really have an up or down because it's completely vertical. But it does have this important feature that it always goes through the same point. In this case, it always goes through an x point. So this particular line goes through x, 2, 4. And that means that every single point on this line has x equals 4. When y is 20, x equals 4. When y is 10, x equals 4. When y is 0, x equals 4. So all you need for the equation is that component. And we call this undefined slope. So if you see a line where it says x equals, it's vertical, and y equals, it would be horizontal going through the y point. Now, for this particular section, it's really important to have all our formulas and letters and notation correct and working through with our correct variables. So there's a couple key things that we need to pay attention to here. Number 1, slope is not represented in an equation by an s like we might instinctively think. Slope is represented by an m. So whenever you see the letter m, that's what I'm talking about. I'm talking about slope. So in this case, when we look at this equation here, when I say m equals, I mean slope equals. And rise is the vertical or up and down change. And your run is your horizontal. And in this case, always going from left to right. change. So if I started at one point on the graph and I picked another point, how much did I have to go up and down? How much do I have to go to the right? So we've got those two different things that we're going to look at. This is really important. I'm going to kind of circle, highlight, make sure you're aware. This is a good thing to put in your survival guide. Make sure that you know this. You're going to come back to it all the way through this entire unit. So slope equals rise over run is one of the most important key points to the entire vertical course. So we're going to look at this with actually doing graphs. So I'm going to do the table part of this one fairly quickly, but the idea again is that reminder that our slope equals rise over run. So we're going to come to what that actually means, and when you visually see it, it might make a bit more sense to you. So the idea here is we've got an equation 3x plus 1. So I'm going to make a little table of values so I can graph this, and I'm just doing this so we can remember that this is what we were doing in lesson, the first lesson for this week. And I tend to pick a few negative values and a few positive values. So let's go -2, -1. Those are pretty good ones to try. And then we sub these into the equation. I'm going to show that for the first one, but I'm not going to show it for every single one, just for the sake of time on the video. So -2 times 3, so we go 3 times -2 is -6, plus 1 is -5. And then you would do the same thing again. 3 times -1, all right, that's -3, -3 plus 1. You guys got -2. And then you're going to do the same thing. You're going to plug the 0 in. 3 times 0 is 0. 0 plus 1 is now +1. And we're going to keep doing that. I'm going to sub the 1 in. 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6, plus 1 is 7. And 3 times 3 is 9, plus 1 is 10. And those are all the points that are going to go on our grid. Now I try to basically make a grid. The reason why I didn't draw the lines in yet is because it gives you a chance to kind of take a look and see what kind of grid you want to have. So if you are drawing your own, you don't always have to have your scale go up by ones, and your X scale and your Y scale don't have to be the same thing. That's the other thing to not get stuck on. So I want to make sure that I can fit in the -5s. So 5, 4, 3, 2, 1. I'm going to make 0 here, and I'm going to make sure I can fit as many points as possible on this grid. If I don't get all of them, that's okay. There's your x-axis, your horizontal. There's your y. And then I'm going to sub each of these points. -2, -5. -2 is my x. 1, 2, 3, 4. -5 is down here. -1 and -2. -1 in the x direction. -2 in the y direction. 0 and 1. 0 and 1. 1 and 4. 1, 1, 2, 3, 4 vertical. 2 and 7, 2, 1, 2, 3, 4, 5, 6, 7. And that last point doesn't fit on the grid. That's okay. When you're doing straight lines, if you don't get every single one in there, it's not the end of the world, because they will basically all connect into a nice straight line as you go. So that's the reminder of graphing from yesterday. Now, how do we use this to actually figure out our slope? What you need to do is pick 2 points on this line that are really easy to identify. You want to pick ones that don't have decimals. So you want to pick ones that are right in a little X spot like this. So basically all the ones we just did are great points. So I'm going to kind of start with, I don't know, let's pick this guy because he's right in the crosshairs. And I'm going to pick this guy because he's right in the crosshairs of 2 points. And then what you do is you build yourself a little triangle. The idea with your triangle is you always want to go from left to right for your rise, or for your run, sorry. And then you want to go in the same direction. I try to go in the same direction that my line is going in. So since my line is going upwards, I'm going to make a right angle triangle that goes up until I get to the same level as my next point, and then goes over. And you create a little triangle that basically connects your first point to your second point, going upwards because my line is going upwards. If you did it the other way, it'll still work, but there's a reason why I like doing them this way. And then you're going to basically count and say, what is my rise? This is your rise, and these spaces is your run. So you're going to count and say, how much did my graph rise by to get from this point to this point? It went up 1, 2, 3 units. So your rise in this case, I'm going to find a pen that writes a little bit nicer there. Your rise equals 3 units. You went up 3 units. And your run, you moved over horizontally 1 unit. So down here on the rest of the sheet, we have rise over run. Remember that your rise is your vertical. Your run is the horizontal. So rise can go up or down, horizontal goes left to right. So we rose 3 units. Our rise was 1 unit. So your slope, which is rise over run, equals 3 over 1. And in this case, you simplify that just down to 3. You don't have to keep the fraction. So the slope of this relationship is 3. Now I'm going to try this one more time with another graph, and I'm purposely picking one that decreases because this is where I see more errors. So we're going to do this straight from a graph. We're not going to do a table of values. And I'm going to find 2 points that work. You want to find ones, again, that fit nicely, kind of like, as I said, in the little crosshairs between where things actually where the line actually crosses, that's right in a corner. So I'm going to pick this one because the 0, 0 point's a nice one. And then I'm going to look down my line or up my line, it doesn't matter, and I'm going to keep going down the line until I find one that, boom, right there is right in a little corner again. So those are the 2 points I'm going to pick. And then I'm going to make myself a triangle. Now in this case, this line is going down. So to get from this point to this point, I have to go down and then over. So there is my rise over run triangle. And so then I kind of count. Now in this case, I also changed the scale because I want you to get used to the idea it's not the number of squares, it's the number of units. So since this one goes to 10 every 5 squares, this is 2, 4, 6, 8, 10. So what you're going to need to do is instead of counting 1, 2 squares, you need to remember they're worth 2, 4 units. So your rise equals -4 because you're going down 2, 4. And then your run, which is your horizontal. Always think running is like running across something horizontally. You don't tend to run straight up. Again, every square is in the units of 2, so you have to go 2, 4, 6. My run equals 6, and this can make a difference to your final answers. Now, how do you show this? I always want to see your triangles on your graphs. It helps to make sure that I can see which points you're actually using. And then when you find slope, you go m equals rise over run. Your rise was -4 because you were decreasing. The negative's important. It gets forgotten all the time, and I'll see a lot of just 4s here, but that would be a totally different graph. That would be a graph that's going up this way then, instead of down. You need this negative on this rise. And then your run is 6. Now that's correct, but we always want this in lowest terms, so you have to think about the idea of how do we put this in lowest terms. Well, 4 can be divided by 2 into 2 to give you -2. 3 divides by 2, or sorry, 6 divides by 2 to give you 3. And there is your slope. So not only does it go down 4 units and over 6, but I can also say it goes down 2 units and over 3, which makes sense. That would be 1 square and 1.5 squares, and that also falls right on our line. So the lowest terms is what you would put, and this will be useful when you do the next lesson where you're going to use this in an entire equation. So I'm going to take a stop at this video. The second half of this lesson will be in the second video. I just want to make them a little shorter so they're a little easier to load. If you have any questions about this, please make sure that you check in with your teachers and ask any questions that you do feel are relevant or if you're confused on. Thank you.